Hello. Hope you're all doing fine. We're going to be continuing with section 2.3, which is exploring the rational zero test. Okay? So we've already talked a little bit about it, and we talked about synthetic division. The rational zero test, as a refresher, we had the factors of the constant over the factors of the coefficient. Now, these are every possible, remember I say possible, real rational zero. Okay, so this is just rational zeros. And I should put possible right there. Okay, so we're looking at possible rational zeros. And it's written as not Q, it's written as P over Q. So let me just erase that. Maybe I press undo. Good. It's P over Q. And these are all of our possible zeros. Now, remember the factors of a constant term, they can be plus or minus. Okay, so we're going to be using plus or minus quite a bit. We already went through one example, which was x cubed plus x plus 1. And we said that the coefficient was 1, so our possible values are plus or minus 1, and our possible values for a constant are plus or minus 1. But we have to test these out because this equals plus or minus 1. So we have to test these out inside of our equation. So make sure I write that equals f of x. So we have to check f of 1 and plug in each of these values and decide whether it equals 0. And this does not equal 0. And you can try it out for yourself if you liked. Or f of x, where x is negative 1, also does not equal 0. So for this particular equation and function, we have no rational zeros. All right, so let's look at another example, because the more examples we have, probably the better. All right, let's choose black. All right, so let's take f of x equals 2x cubed plus 3x squared minus 8x plus 3. Our leading coefficient is 2, and our constant value is 3. All right, so we have to think about factors of 3 and factors of 2. Now, we use plus or minus for these as well because we can have a negative 3 times a negative 1. We can have a 1 times 3. Those are our two options for 3. So we have plus or minus 1, comma, plus or minus 3. And then we have factors of 2, which are plus or minus 1 and plus or minus 2. Oops. All right, so with this comma, that means we have to set up every single possible scenario. So wouldn't that be 1 over 1 could be 1, is one possible 0. Negative 1 is the other possible 0, so I'll go ahead and put plus or minus 1. We now do 1 over 2 and negative 1 over 2, so we have plus or minus 1 half. What's another one? Plus or minus 3 and plus or minus 1, that would be plus or minus just 3. And lastly, we have plus or minus 3 over plus or minus 2, which is plus or minus 3 over 2. So I'm taking each of these terms right here and finding all the possible values. So now we have 8 possible zeros that are rational. Now, we need to figure out which ones actually work, and it takes a long time to check every single one of those. You plug them in, figure it out, plug them in, figure it out, plug them in, figure it out. It just takes too much time. But if once we find one of them, then we can rewrite our equation with that particular value taken out. Okay? So what I'm going to do is I'm going to take, we're going to start with positive 1, and I'm going to use synthetic division to find if 1 is a factor or is a real 0. And if it is a real 0, that means x minus 1 factors into our polynomial. So let's go ahead and do this. We have 1, and we use 2, 3, negative 8, and 3. So the first thing we do, we bring down 2. We have 2 here. 2 multiplied by 1 is 2. And 2 plus 3 is 5. 5 times 1 is 5. And we have negative 3 as our answer, because negative 8 plus 5 is negative 3. And then lastly, we multiply 1 by negative 3, and we get negative 3. And so we have 0. So if the remainder is 0, then 1 is a rational 0. Which means that x minus 1 factors into the polynomial up there, factors into f of x. So we can rewrite this now with our new dividend. Okay? So we have x minus 1, and we have 2x squared plus 5x minus 3. All right, now with this we can check more values if you'd like, or we can simply try to factor it. And it turns out this factors really nicely. This equals x minus 1 times 2x minus 1 and x plus 3. So we now have our real zeros. We have our real rational zeros. So our rational zeros and for this one it's all of our zeros equal 1. This is going to be 1/2, and this is going to be negative 3. Now notice that these are also possible answers. We have 1/2. Cool. There's 1/2 right here. And then we have negative 3 as our possible. So we didn't have to check every single one of those. And that saves us time. So that was the whole point of this. We found our rational zeros. Fantastic. Okay, so I'd like you to try the same thing here. Here's our f of x. And our f of x equals 10x to the third minus 15x squared minus 16x plus 12. And hopefully you're thinking, oh man, factors of 10, factors of 12, goodness. Well, guess what? What we can use is our graphing calculator device. I'm recording. Go away. Graphing calculator device, graphing device calculator, our GDC, to estimate possible rational zeros. Now, that's for big factors. For other things, I'd like you to try it out. So most of them will be pretty good. And what happens is you get a graph here that looks something like, I believe it looks like it gets really close to -1, but it doesn't actually go through it. It goes down and then it comes up, and it looks like it touches at 2. So we're going to take undo. We're going to take 2 comma 0, and take that 2 and see if it synthesizes. If you can synthetically divide it by our factors up here. So we have our coefficients, 10, negative 15, negative 16, and 12. So how about you do that for yourself and see if 2 is a possible rational 0, if it is a rational 0. All right, so let's go ahead and do that. If you did it on your own, you can check your work. This is 10. This is 20. This is going to be 5. So we have 5 here. This is going to be 10, which brings us to negative 6. And negative 6 times 2 is negative 12, which is 0. Yeah, awesome. All right, so now we know that x plus 2, it's x minus 2 is a answer, and it factors in 10x squared plus 5x minus 6, and we can see if this factors. It turns out it doesn't factor. So once you get to this point, if it doesn't factor, it doesn't have a rational 0. This is the only rational 0 is 2, so we can use the quadratic formula, or we can use completing the square to find the other zeros. Okay, so you can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a, and find the other zeros. So our only rational 0 is 2. Okay? The rest of it looks like this. All right? So that's synthetic division for you. I can give you a few more problems. But remember the factors of 10 and 12, there's quite a few here. So if we were to look at the factors of 10 and 12, we'll go ahead and write that out real quick. It was 10x cubed minus 15x squared minus 16x plus 12. And remember, our constant factors are up top. So we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. I'm taking factors of 12 right now. Plus or minus 6, and plus or minus 12. All over 10. Factors of 10. Plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Okay? You can understand that there are a lot of possible answers. A lot of possible answers. So using the graphing calculator to estimate is why we did that. All right, your homework for tonight. You are going to be looking at page 170 through 171. I want you to do numbers, let's see, 19 through 27 odd. I want you to do 35 through 38. And I want you to do 39 through 44. Make sure there's no remainder thing in here. I don't think there is. And I want you to do, like the last one, do 60, 63, and how about 67? All right. Thanks a lot. Ciao.